Hello, I'm Illustrator's Illustration. I'm Chemist Reacts, and now I would like to try explaining Katana in Dr. Stone with the chemist knowledge that I have. Hyoga attacked Ishigami village during celebration time, which is very bad for the village, because Hyoga's power with his signature spear is on par with Tsukasa. What weapon of science can beat Hyoga and his lackeys other than gun? Because Senku has no more gunpowder, and he used the last of it as bluff. Insert Japanese-style katanas to fight Japanese people that know how fearsome the katanas are. Let's also review my previous video about episode 8 to 9, and start there. Senku used a bloomery to turn his magnetite iron sand into iron. Normally, bloomery makes spongy iron called bloom, but Senku's iron is molten and can be casted. Also industrially, blast furnaces are used, and the products are called pig iron. They all contain mostly metallic iron, but they also contain 2 to 6% carbon, and that's too much. With that much carbon, these kinds of iron are brittle. If the bloomery is controlled carefully to make low carbon bloom, we can remove some or almost all of the carbon by hammering it, and the impurities will fly away as sparks. If we do it to the extreme, the carbon content can go as low as 0.08%, and that's wrought iron. Alternatively, the high carbon iron can be melted, and the carbon is burned away in oxidation to make steel. It needs this kind of furnace though. If we stop at around 1% carbon, we have the very versatile steel. Regarding the folding, Senku said that twice is enough. What I found similar to that is this. It seems that 3 or 12 foldings, high carbon and low carbon iron still coexist in the iron microstructure. Another special thing about Japanese sword is the heat treatment part. As Kaseki puts it, the blade of the sword is made strong for cutting, and the back is made flexible for parrying. As with Senku, he mentioned stuff like martensite and semi-ferrite. Those are pieces of iron carbon alloy, aka steel. So with steel, in high temperature they adopt a structure called austenite. In this austenite structure, the iron atoms are densely packed, along with some carbon here and there. When it's cooled slowly, like on the back of the sword, it adopts a structure called ferrite. Ferrite is loosely packed compared to previous austenite, so the iron atoms are also a little bit loose and can move a bit freely, so it's more flexible. If you look at Wikipedia, perlite is mentioned instead. What I understand, perlite is just a mix of mostly ferrite and a little bit of regions of high carbon iron called cementite. That's why Senku calls it semi-ferrite. On the other hand, if it's cooled quickly, the austenite doesn't have the time to change structure. We call the new structure martensite. Even though austenite is described as face-centered cubic and martensite is described as body-centered tetragonal, from a certain point of view, martensite is basically the same structure as austenite, as seen in this diagram. This diagram basically says all you have to do to turn austenite into martensite is changing your perspective. Just like austenite, in martensite the iron atoms are still densely packed, so it cannot slide as much, and we perceive this as hardness. In conclusion, to make steel like in Japanese katanas, the high carbon content from previous iron processing is removed by hammering, folding, and basically working hard on it. I found one paper that says 3 foldings are similar to 12 foldings. During the heat treating, the steel in the sword forms 2 different phases. In one, the atoms are loose and flexible, and in another, the atoms are tight and hard, just like when they were when the sword was hot. That's all I have for now. You might want to watch my episode 9 video, as it was related to this episode. Do you guys notice that the Kingdom of Science has extra steel to make shield for Kinko?